Hello friends of EduMath, welcome to the third part of motion under gravity. So if you are new at EduMath, subscribe so that you can receive our new uploads whenever we make them. For now, let us get started with a guiding question. So the first guiding question is here. We should be able to recall that here we are going to be modifying the equations of motion. Alright? So when the particle is vertically projected upward, the acceleration is equivalent to the acceleration due to gravity, and it's going to be a negative acceleration. If it is vertically projected downwards, the acceleration will be a positive acceleration due to gravity. Let's get started with a sketch diagram. A stone A is fired vertically upwards with a speed of 40 meters per second. So we're going to fire it from here, then it will reach the maximum point until it come down to the ground. So this is the stone A. And 1 second later, another stone B is projected from the same point with the same speed. So we have stone B. This is the same point. So I'm to project it here. They need us to find the time that elapses before they collide. So this is the point of collision. This is stone B also being projected upwards. We can have here the summary for stone A and then for stone B. Both of them were projected at the same speed, which is 40 meters per second. Then, if stone A moves within a time of t seconds, they are telling us that 1 second later, another stone B is projected, meaning that stone B delayed for 1 second. So we shall have its time being t minus 1 seconds. Both of them are projected upwards, so this is going to be negative g, and the acceleration here is also negative g. Now, at the point of collision, let's say this point here, point of collision, both stones A and B are the same height above the ground. So I can call that height to be h. So displacement here is h, and displacement here is also h above the ground. So now using the displacement is equal to ut plus a half at squared, we are going to consider the respective stones. So for stone A, displacement is h. This is equal to u is 40, t, we need to find the t, minus a half times 9.8. This minus comes in because this is going to be negative 9.8, the acceleration, t squared. So h is going to be 40t minus 4.9 t squared. Can call this equation 1. For stone B, we again substitute this information in that second equation. So we modify it. We have the height was the same, h being equal to u is 40, then the time is t minus 1 minus a half. Our acceleration is 9.8, but of course it's negative. Why? Because we are moving against gravity. The time is t minus 1 squared. Right? So on simplifying here, we have h being equal to 40 into bracket t minus 1 minus 4.9 into bracket t minus 1 squared. Right? Opening here this bracket here, further simplifying this, we have h is equal to 40t minus 40 minus 4.9 into bracket. We need to expand this bracket here. That is t squared minus 2t plus 1. So h is equal to 40t minus 40 minus 4.9 t squared plus 9.8 t minus 4.9. Collecting like terms, h is equal to 49.8 t, this and that, minus 4.9 t squared, minus 44.9. Now, we call this equation 2. At the point of collision, these two stones are at the same height, and that height is h. So we are going to equate equation 1 to equation 2. So we shall have 40t minus 4.9 t squared. This is from equation 1, yeah, equaling to equation 2, which is 49.8 t minus 4.9 t squared minus 44.9. Right, so some terms are going to go away, so we shall have that term and that term going away. So when 49.8 t crosses to this side, we shall have negative 9.8 t equal to negative 44.9. And from here, when you divide both sides by 9.8 negative, we shall have to get t as 4.582 seconds. So the time that elapses before the two stones collide is 4.582 seconds. In our part B, they need us to find the height above the point of projection at which they meet. So they need us to find h here. We are going to make use of equation 1 now that we have got t. So from equation 1, we have that h is equal to 40t minus 4.9t squared, and t is 4.582 seconds. So we substitute, h is going to be 40 times t, which is 4.582, minus 4.9 times 4.582 power 2 here. So when you simplify, our h is going to be a value which is 80.41 meters. So that's where the two stones collide after projection. A missile is fired vertically upwards with speed 47 meters per second. Now they need us to find three significant figures: the time that elapses before the missile returns to the firing position if the missile is projected from two different positions, that is at the seashore and at the mountain. So we start by having a sketch. So we're going to have a missile projected upwards. We expect it to come back at the same position. So it is projected from this point here. U is 47 meters per second. If this particle has to come back to this very point, then the final speed there will be negative 47 meters per second. Now, since it was projected upwards, the acceleration upwards is negative g. So, using v is equal to u plus at, the final velocity is negative 47, being equal to the initial velocity, which is positive 47, minus, now for part A, our g is 9.819, and then we need to find the t. So when you simplify this, my dear viewer, we shall get t as 9.57 seconds, and they needed these to three significant figures. That is part A. Now part B, we are going to change this here. So using v being equal to u plus at, still the final velocity will be negative 47, being equal to initial velocity 47 minus, because it is projected against gravity, which is 9.783 t, right? On simplifying, our t will be 9.61 seconds here. And this is for part B. In another trial question here, a youth playing with a football in a garden surrounded by a wall 2.5 meters high and kicks the ball vertically up from a height of 0.4 meters with a speed of 14 meters per second. You need us to find how long the ball is above the height of the wall. So first we need to make a sketch of that question. So first we have the wall here. The wall is of height 2.5 meters. Now the boy kicks the ball vertically up from a height of 0.4. So we have here a height of 0.4. So the ball is going to be kicked from this point here going upwards. So there the ball is kicked, it will pass by the wall up and it will come back to the ground this side. Now they need us to find how long the ball is above the wall. So they need us to find the time taken when the ball is above here. So we know that the initial velocity is 14 meters per second. The displacement of the ball is going to be the whole of 2.5 minus 0.4. That's the displacement of the ball, which is giving us 2.1 meters. Now, this ball is kicked upwards, meaning that the acceleration is going to be negative g. So using the displacement is equal to ut plus a half at squared, we need to modify this. We shall have our displacement, which is 2.1, being equal to our u, 14, times our time, which we do not know yet, minus a half times 9.8, that is the acceleration due to gravity, and this negative shows that we are opposing it, t squared. So 2.1 is equal to 14t minus 4.9t squared. So rearranging this in quadratic form, we shall have 4.9t squared minus 14t plus 2.1 equal to 0. Now, my dear viewer, I know I'm dealing with advanced level students. So you're going to solve the quadratic. So you can first pause the video to solve the quadratic here, and then you'll confirm to me that t is going to be equal to 2.698 seconds, or t is going to be equal to 0.15883 seconds. Now, this implies that the time taken for this ball to be at this height first is going to be equal to t here is 0.15883 seconds. Then to be again at this very height here, the time taken there will be 2.698 seconds. The question demands us to find how long the ball is above the height of the wall. So above the height of the wall is that journey there. Final time when it is above the height of 2.5 minus the initial time here. 2.698 minus 0.15883. So this is equal to 2.5392 seconds, and this is to 3 significant figures. Okay. Now to you, my dear viewer, I would like to thank you so much for being part of EduMath. We always wish you the best, and we say God bless you. See you in the next video.